Hello. So, in this video, we're going to be tackling what is arguably one of the most intuitive theorems in the class, even though when we first read it, it seems really sort of dense and difficult to understand. And that theorem's the intermediate value theorem. So before we sort of jump into it, I want to sort of preface this by saying that this is a type of theorem called an existence theorem. And this is something that you have probably not seen this kind of theorem yet in your sort of math career. And the key difference between an existence theorem and other types of theorems, like construction theorems, is that existence theorems tells you an answer exists, but it doesn't tell you what an answer is. Now, you might wonder why that's useful, right? Because like, if you need an answer and just knowing one exists, how is that sort of helpful? And it turns out that actually it's incredibly helpful, deceptively so. And so we're going to talk a little bit about that in this video, and then we have example videos as well to show sort of in practice how this is used. So as mentioned, the intermediate value theorem. So this theorem, I'm going to sort of read through it, but then I'm going to translate it into, human speak. So the theorem says, let f be a function from R to R, so it's a real valued function, and continuous on some interval a to b. Then for any value k between f of a and f of b, so for any y value between these, there exists some c between a and b such that f of c equals k. All right, so as mentioned, this is probably just sort of a lot of math notation thrown at you. It's sort of hard to understand what's happening here. And realistically, in order to see what happens, it's actually best to literally see what's happening. So that's what we're going to do. We're going to look at what's happening here. So let's say we have a function, and we know 2 points of that function. We have some point over here at -2, 2, and we have some other point here at whatever this is, like 5, 6, right? So in our sort of original notational meaning, so if I go back a second here, that would be the a and the b up here, right? So if I'm looking at the ab here, that corresponds to these x values, this -2 and the +5, right? And then the y values, the 2 and the 6, those correlate to the f of a and f of b, okay? So that's what we're talking about. The f of a and f of b are the y values. The a and the b themselves are the x values for this, these 2 points that we have. So then the intermediate value theorem tells us, okay, let's say we want some y value between those two. So I'm going to draw a line here representing all possible sort of y values at any given x value, right? So I have this nice flat curve going across of value k, right? This, again, corresponds to that k in our definition. So what the intermediate value theorem says is that if our function is continuous, then we have to get from one of these points, right, this point down here, to that point up there, and in doing so, we have to cross that line k. So for example, maybe it's just a nice straight line. We go straight through, right? But we don't, we only know those 2 points. We don't know what the function actually looks like. So it could also look, for example, like a parabola, like this kind of thing, right? Or it might look like something much stranger. Maybe it looks like this weird sort of other piece here, which you may or may not recognize, look kind of like a cube root, but that doesn't matter. Point is, it could be any of these 3 lines. We don't actually know what the function looks like. All we know is that it has to go from one point, like this one, to the other point up here. And because it's continuous, right, I have to draw from one to the other without picking up the pencil, right, that graphical idea of continuity. There's no way to go from one of these points to the other without crossing this line, which means that somewhere, say right here, I'm going to have a x value between -2 and 5, where I hit that k value, meaning that the y value at that x value is k, right? So this is what the intermediate value theorem says. But at the same time, it's also telling me that I could have different curves. I don't know what the curve looks like. So although I know I have to hit the line because I can't go from one point to the other without hitting that line, I don't know where. And this is why it's an existence theorem, right? So it's not telling me where I hit the line. It's not telling me what the x value is that gets me that k. It just tells me that it has to be somewhere between those 2 points, that a and b, okay? So different curves are hitting the dotted line in different places, but it still has to hit it somewhere. And the key there, right, the second piece, is that the function has to be continuous for that to make sense, right? It's the continuity that's really driving this. It's making it so I can't just sort of pick up the pencil, skip the dotted line, put the pencil back down again, and continue on. So I have to have that my function is continuous, and that's sort of what's forcing me to hit that dotted line for any value k, okay? So in general, what did we learn? So we talked about the intermediate value theorem. The intermediate value theorem is sort of one of these first examples of a theorem that is an existence theorem, right? So it tells us that it hits a point, but not necessarily what the point is. So in other words, it doesn't give you an answer in the sense of an actual x value or some point, right? It doesn't tell you exactly where you're hitting that line k, but rather it tells you that there is an answer to find in the first place. And it turns out that this can be, again, deceptively useful, often used sort of the other way, like knowing whether or not it's possible to hit the line, to hit that point is useful. But as mentioned, we're gonna have some example videos going through actual sort of real problems and figure out how to actually find these things. Okay, so that is that.